Hello, and welcome to another episode of Season 2 of Tierah Ruins Things with Science. I am Tierah, here once again to ruin another favorite movie or TV show that mentions an infectious disease by comparing it to the actual science. I have a degree in immunology and a master's in medical science, and I love watching movies and shows and everything, so I combined them into this podcast. Today I'm going to be talking about polio as featured in the movie Warm Springs, which is an HBO TV movie from 2005 starring Kenneth Branagh as the US President Franklin Delano Roosevelt and Cynthia Nixon as his wife Eleanor. Polio used to kill around 500,000 people a year during the 40s and 50s, and it paralyzed countless more, millions of people. Due to vaccination campaigns, the WHO estimates that around 20 million people today are not paralyzed who would have been through catching this virus if the global vaccination efforts had not been as successful as they have been, in large part due to the publicity and fundraising efforts put together by people like FDR. That's why I believe that polio is a worthy inclusion in this season that's all about world-changing infections. You can watch Warm Springs on Prime Video, depending on your region, and it's available on all of the rental platforms out there.
Mr. Roosevelt.
Teddy?
No, he's dead.
So, polio. I'm guessing that most people under the age of 40, unless you've seen this movie, have very little familiarity with this particular virus since it is very close to being eradicated. In the late 1980s, there were around 350,000 cases a year across 125 different countries. That's just cases, not deaths, but thanks to the Global Vaccine Initiative, in 2021, there were just 6 cases of wild poliovirus strain number 1. That is 6 across the entire planet. Wild poliovirus strain number 2 was officially declared eliminated in 2015, and strain 3 was declared eradicated in 2019. So there's only number 1 left, and we're very close to full eradication. Unfortunately, cases have been going up and down a little, with 22 worldwide in 2022, 12 in 2023, and 11 in 2024. I will talk about this more a bit later, but my point is that kids these days, the Gen Zs and the Gen Alphas, are so incredibly fortunate to have grown up in a world basically free from the threat of polio, whereas within my lifetime, polio was still a major disease. Anti-vaxxers, or I guess even just the vaccine hesitant or vaccine worried, this part is for you. All of you people out there who say, well, people were just fine before vaccines. No, they weren't, Tammy Lynn. They died, most often as children. Whether from polio or one of the other diseases I'm covering this season, kids were not fine before vaccines. They were dead. As with many other viruses and diseases, including typhoid fever mentioned in a previous episode, this virus is a poop-transmitted infection, which means that if you catch it, sorry, but it means that's because you got something in your mouth that was contaminated by raw sewage. I will, in this episode, keep the poop talk to a minimum, but I did my master's degree studying fecal transplantation in a pig barn, and I've kind of lost the ability to know when it's okay to talk about poop. All those poor men who asked me what I studied for my master's on a first date, yeah. You might remember that it was just recently, in March of 2024, that one of the last 2 people living in an iron lung passed away. His name was Paul Alexander, and he caught polio in early 1952 and had been using an iron lung ever since, for 72 years, making him 78 years old. Depending on what early in 1952 means, I couldn't find out the exact date. He may have been using an iron lung since before Queen Elizabeth II became queen, which happened on February 6, 1952. He outlasted her reign by a few years, so that puts the length of time that he was in an iron lung into perspective. He lived in one for a longer span than QE2, the longest-serving British monarch, was on the throne. So an iron lung is basically a long capsule that a person lies in on a bed with just their head sticking out one end, and it's sealed around their body with a flexible membrane so that the pressure inside the lung can be increased and decreased to force air in and out of their lungs like a bellows. Because polio causes permanent paralysis, and depending on what part of the spinal cord is affected, The person can lose the ability to breathe on their own, and an iron lung is better than having a tube down their throat all the time. FDR was not paralyzed that high, so he needed a wheelchair, not an iron lung. The other person, now the last one living in an iron lung, is a woman named Martha Lillard, and she caught polio in 1953, a year after Alexander. I've got some links in the sources, which you can find in the show notes, to articles where you can see some pictures of iron lungs and people using them. You might have heard of or read about these two people. They're famous for having polio. There's a big list of people that I knew were famous for other reasons, but who happened to have contracted polio and recovered from it. Some names you might recognize are Frida Kahlo, Mia Farrow, Alan Alda, Donald Sutherland, Joni Mitchell, Neil Young, Francis Ford Coppola, Arthur C. Clarke, Mary Berry, the former host of the Great British Baking Show, Itzhak Perlman, the violinist who you might know from the Schindler's List theme written by John Williams, Paul Martin, the former Prime Minister of Canada from 2003 to 2006, and also his father, Paul Martin Sr. This disease is not ancient history. There are people still alive who had it as kids, and there are still people catching it today. Mitch McConnell, I think you'll probably know who he is. Jack Nicklaus, the golfer. Emmett Till, the 14-year-old black teenager who was wrongly accused of being inappropriate with a white woman in a store, who was then abducted and lynched. Polio affected him at age 5 and left him with a stutter. And it kind of got me wondering whether or not that played into what happened to him, because he was accused of whistling at a white woman who lied and just made it up, and not to yada, yada, yada this, but it's more than I can get into in this podcast. It does make you think whether or not polio could have played a role in how he was moving or behaving or the expression on his face that led in part to the whole situation. It honestly wouldn't surprise me. And then, of course, we have former US President Franklin Delano Roosevelt. Now, it is broadly accepted that FDR had polio, of course, that's why I'm doing this episode. But there are some who think he had something else instead, and I just wanted to address that first. There are a lot of issues when it comes to diagnosing people in the past. They're essentially historical figures. Even this recent in the past, we don't have physical evidence or samples to test to see what killed or infected them in most cases. Sometimes we can do it for long deceased people, like victims of the Black Death. I talked about that in season 1, and I'm going to mention this all again in episode 6 when I talk about tuberculosis. Most often, though, we're stuck with a bunch of weird and or vague symptoms that we can't really nail down to being just one thing. Or there's symptoms that don't match any known modern diseases, like a sweating sickness or the dancing plague. We don't know what caused those. There are a lot of diseases that have flu-like symptoms, fever, paralysis, and digestive tract involvement, i.e. shitting your pants. It's often impossible to parse which illness it could be from a description like that, just based on the historical accounts. The farther back in time you go, the harder it is. If you're relying on written records, are the records complete? Did they write down all the important symptoms? Did they miss some? And then was that person or the people in question on any medications? Were they taking anything? Was the illness caused by genetics, or was it a poisoning or something infectious? It's really complicated. FDR came down with symptoms in 1921, so over 100 years by this point. His treatment was overseen by physician Robert Lovett, who was a professor of surgery at Harvard at the time and was the leading expert on polio in the entire United States. He had personally cared for over 5,000 polio patients in the previous 5 years. He knew what was polio and what wasn't. As of 2003 and then again in 2017, when the same authors wrote a book about this, some people have asserted that rather than polio, FDR had Guillain-Barré syndrome. This illness, it came up briefly in episode 2 of this season when I was talking about the 1918 influenza, and I promised you a more in-depth discussion, so now I'm going to keep that promise. As I mentioned, Guillain-Barré can present very similarly to polio. It also involves an ascending paralysis, so it starts in the feet or legs and moves its way up the body until eventually the arms and face can be involved, and the lungs, meaning you have trouble breathing on your own. It doesn't always get that far, though. Just like in polio, the paralysis can stop at any point in the body. In Guillain-Barré, which I'm just going to call GBS from now on, your symptoms are unexplained nerve sensations called paresthesias, which means you feel things that aren't there or don't have any observable source. So think tingling, pains in absence of any stimulation or touch, pins and needles, and the sensation of bugs crawling on your skin, which, I would die. That's horrible just to have that sensation. It's so bad. I hate it. But also, I have to share something funny. That sensation has a clinical name, and I'm going to enunciate this word very, very carefully because the word for the sensation of bugs crawling on your skin is formication. That's formication with an M for motel. So, a long time ago, just after high school, my sister and I were living together, and our friends would come over after work and we would play balderdash for hours. We didn't have a game board at this time. We'd just pass an old dictionary around, and everyone would take turns choosing a word at random, and everyone would make up a definition. And one of the words that we encountered at this time was that word, formication. I don't remember what the definitions we came up with it were, but it was pretty funny. Anyways, that would suck. That would suck to have that when there was nothing you could do about it. I would probably scratch all my skin off. Other symptoms of GBS include vision problems, issues with swallowing, speaking, chewing, abnormal heart rate or blood pressure, trouble walking, and problems with your digestion and your excretion too. The big difference, though, is that GBS is actually an autoimmune condition. So, your immune system will attack the myelin sheath that covers the neurons that transmit sensations in your body to your brain. It's very similar to multiple sclerosis. Or it can attack the neuron itself and cause the same issues. The difference between MS and GBS is the speed at which the loss of function happens. They're both autoimmune conditions, but with MS, it's slowly over a period of many years and the loss of sensation is permanent, while GBS takes 1 to 2 weeks to come on and it's almost always not permanent. GBS mainly occurs in people over 50, and it's not known what causes the autoimmunity to trigger, like what specific protein or antigen your immune system sees or encounters that causes it to be confused and attack your own cells. But when it does occur, it's usually after a viral infection of some kind. There are some studies from around the world that have reported an increased incidence of GBS after infection with some viruses like COVID-19, Zika virus, cytomegalovirus, or Epstein-Barr virus. Now, these are just associations, they're not necessarily causation, so don't be hasty. We haven't proven anything yet. The main difference between GBS and polio or MS is that most people who get GBS recover fully eventually. There's sometimes this lingering weakness or pain in some spots that some people can have, but on the whole, people who develop GBS recover back to almost 100%. The recovery can take long months and it's a lot of work to get there, but they do recover. This is not the case with polio. Polio causes a permanent paralysis, and FDR never recovered. One of the other main differences is that people who get infected with the polio virus, they will develop mid to high grade fevers. You have any infection, and that's one of the main and best ways your body fights it off. And this is not the case with an autoimmune condition. You will not typically develop fevers with an autoimmunity. FDR's case was well documented because even though this was before he was president, he was a politician and a rich white guy from a famous family who could afford good medical care. His doctors kept good records. They published papers about his case and the symptoms and the progression of the disease, so it's easier for us to go back and look at the case. Some signs that are typical of polio that FDR displayed were obviously the loss of function in his legs, the increased sensitivity to touch, which is called hyperesthesia. So light touches can be excruciatingly painful, versus a lack of sensation that is present in GBS and is often permanent or intermittent in that condition. Polio also usually has an intense initial pain in the back and legs during the initial infection in adults. You also get tenderness, weakness, and eventual muscle atrophy due to the lack of use because of the paralysis. So, given all of this, and especially the fevers and the lack of recovery, which are well documented in FDR's case, I think it's safe to say that it was polio and not Guillain-Barré syndrome. I think these signs and symptoms are well displayed in the movie. However, briefly, his initial illness is on the screen. They do show the fevers, the paralysis, and the pains that he was experiencing. Obviously, at the time this was 1921, they didn't have any molecular testing or the ability to do a spinal tap to test the cerebrospinal fluid to prove that it was polio. But again, given the list of symptoms, I think it's clear. As always, I will link a few papers in my sources so you can go read about it yourself if you like. The author of the main paper that I read about this supposed controversy says that the people who decided it was GBS instead of polio were using some sort of probability algorithm math thing that they had invented and designed that they were trying to promote. And what you would do is you would plug a list of symptoms into this algorithm and it would tell you what the probable cause or disease was. But, and this is a direct quote here, their analysis, however, contains serious flaws in symptom omission, inclusion, and interpretation. Those errors may be due to the author's lack of awareness of the differences between the infantile and adult forms of polio, the characterization of symptoms and signs, simple oversight, or other unknown reasons. A statistical analysis of diagnostic probabilities is not valid when several of these significant distinguishing factors are omitted from such an analysis. A careful inclusion of all symptoms, the differentiating significance, and their presence or absence is critical in drawing conclusions. And that is how you say, you're a fucking idiot in formal scientific language. Now, where have I heard that before? Where have I heard about someone deciding a condition is caused by something else because they have a motivation to use the different diagnosis to sell a product to make themselves money? Wakefield. You can't just pick and choose the symptoms that will give you the answer that you want, so you can make a name for yourself as being the person to finally find the correct answer. Science doesn't work like that. We don't try to prove anything. We try to disprove what we believe, actually. And if we can't find evidence to disprove our hypothesis, that's all we say. We say, we failed to disprove this, so alternatively, it may be true.
I thought it only struck children.
Not necessarily.
Okay, let's get into the history of polio. With the caveat of what I discussed above regarding how hard it is to diagnose people in the past with illnesses, the generally accepted earliest known depiction of polio is in an Egyptian funerary stele, which is just an upright carving on a rounded piece of stone that looks like a small headstone. And the one that shows the polio, it dates to between about 1400 to 1365 BCE. It shows a priest walking with a stick for assistance, and I think it's his right foot shows deformities that are typically seen in people who catch polio as a kid. So the leg and the foot are very thin due to muscle atrophy, noticeably thinner than the other leg, and the foot curves so he can't stand flat on it. Obviously, we can't know for sure, but this is most likely the earliest depiction of polio, showing that this disease has been with us for thousands of years. It first got its official description in 1789 by English physician Michael Underwood, who described it as a debility of the lower extremities. In the middle 1800s, it was called Hein-Maden disease after two doctors who were working on it called Jacob Hein and Karl Maden. Despite being a disease known in ancient times, it was actually fairly rare to have someone come down with paralytic polio. Between 75 to 90% of infections are asymptomatic, with only about 1 in 200 being the type where the virus invades the central nervous system, producing the paralysis. Mortality of this type, the frank paralysis, or it's often also called the infantile paralysis because it mostly happened to kids, it has a mortality usually around 10%, but that can be as high as 20% according to some sources that I saw. Asymptomatic infections don't account for the main reason why this was a rare disease, though. Prior to the 1900s, sanitation and hygiene in most of the world was not great. Indoor plumbing wasn't exactly common, but as hygiene and sanitation in cities began to improve, we all of a sudden see massive outbreaks of polio. That's right, you did not mishear that. This poop transmitted disease got worse once better sanitation was in place. And the reasoning is, I find it interesting. Before widespread sanitation, it is highly likely that polio was everywhere and that most babies and toddlers encountered it quite a bit. Where there's sewage, there's polio, and where there's literal sewage in the streets, kids are going to encounter it a lot. Thing is, though, antibodies are a great protection against polio, and as infants, most babies were nursed because formula wasn't common back then yet either, thanks Nestle, and breast milk is very rich in maternal antibodies. This is actually one of the main ways that babies are protected from many illnesses, not just polio, and why it's beneficial to breastfeed wherever possible. The babies were swallowing maternal antibodies in the breast milk at the same time they were encountering the polio virus. As they got older and their own immune systems developed, they were encountering polio because kids stick everything in their mouths, and they were producing their own antibodies in response, in addition to the maternal ones. So that when they stopped breastfeeding, they were still protected due to their own naturally acquired immunity. So polio cases remained low. All the antibodies in the gut were not allowing the virus to escape to the central nervous system where it could then cause disease. In kids, the paralysis is usually limited to one side of the body, whereas for unknown reasons in adults, it's usually on both sides of the body. As sanitation got better, infants and small kids encountered polio less, and this means they never built up immunity to it from repeated exposures as a baby or toddler. And so when it did hit them, they were more likely to not have protection, and then 1 in 200 of them would develop permanent paralytic polio. Beginning around 1900, the US started having localized epidemics of polio that were causing a lot of cases and deaths. There were a few minor notable outbreaks of polio in Austria in 1898, Norway and Sweden in 1904, Vermont in 1894, which took 134 lives, and New York in 1907, which took about 2,500. But between 1910 and 1914, across the United States, there were 5,000 deaths and 30,000 cases reported. In June 1916, there was the first recorded major outbreak right in the middle of World War I. It occurred in Brooklyn, where 27,000 patients were reported and between 6,000 to 8,000 people died. During this outbreak, whole families were quarantined, their addresses were published, and signs were put up on their houses to let people know to avoid them. From then on, it got worse and worse right through the next World War until 1952, when a major wave of virus hit and 3,000 people died and 20,000 people became paralyzed throughout the United States.
Well, your gluteus maximus is better than I'd hoped.
Before I talk about the movie, I want to spend a few minutes talking about poliovirus itself so that we can understand whether the depictions on screen are accurate or not. Its official name is poliomyelitis. Polio is Greek for gray, myelon means marrow, and itis means inflammation, because it causes inflammation and destruction of the gray matter in the spinal cord. As I said at the top, there were 3 strains of the virus, and the only difference between them was the protein shell or the capsid that protects the virus. The proteins were different enough that if you developed immunity to one, that immune memory would only protect against that specific strain of the virus. You could still be infected with the other 2 and get polio if you had only encountered one strain the first time. That would suck, except polio strains 2 and 3 are eradicated now, so at least there's that. The virus almost always spreads through improperly handled sewage, whether that's a body of water that sewage has been released into, or something as simple as not washing your hands after using the toilet. This allows for it to rapidly spread amongst family members because of the close contact involved in living together, and because people are nasty and don't wash their hands. Very rarely you can catch it through respiratory droplets or nasal secretions, so like if someone coughed or sneezed directly on you during their initial infection when they had a fever, it's gross, but you might catch it that way. As an enterovirus, though, it replicates in your enteric, aka your gastrointestinal system. So the things that come out of all parts of that system are potential infection points for the virus, from your nose and mouth to your butthole. But for most people who encounter the virus, 90 to 95% of them will show no symptoms at all. Between 4 and 8% will have a short, self-limiting, flu-like sort of illness, and the rest will develop the paralytic polio. The incubation period is anywhere from, say, 2 days to a month or so before you start to experience symptoms and shed the virus. The length of time, it possibly depends on the dose of the virus that you were infected with. So it begins to infect the cells of your mouth and your tonsils and your lymph nodes, and then it moves down into the small intestine and begins infecting your gut cells that line your intestine there. You begin shedding virus a couple days before showing symptoms and for up to a week after you do start experiencing them. For 1 in 200 people, the illness is not self-limiting and they go on to develop paralytic polio. When that happens, the virus breaks through the gut and infects the central nervous system because the gut and your CNS are directly connected through a large nerve network. People who are asymptomatic or who show symptoms but clear the virus before it can leave the gut, it's possible that they just have a better antibody response to the virus. We all have different immune genes that determine the proteins our antibodies can respond well to. And not only that, we're all in different stages of health on any given day. Immunocompromised or malnourished people will have a weaker immune response. Obviously, being unvaccinated will increase your risk too, but this movie takes place before mass vaccination was common. Other health conditions can also make you more susceptible to severe disease, as with other viruses, not just polio. There's some evidence that muscular injury after exposure to poliovirus can increase the chances of worse disease, including progression to paralysis. There's a study from Romania that showed that kids who got the oral polio vaccine and then sometime in the following 30 days got other shots. In the paper, it said mainly antibiotics. They were receiving intramuscular injections of some kind. These kids were at an increased risk for vaccine associated paralytic polio. There is such a thing as developing polio after the oral vaccine, which is why we have two different polio vaccines, and I'll talk about that later. But intramuscular injury while developing antibodies to polio appears to increase the risk of paralytic polio. Key thing to note there is that the study wasn't wild-caught polio, it was an inactivated polio vaccine, which is already known for having the ability to convert back to a virulent virus, so this mechanism may not be the same as if one encountered polio in the environment. In fact, I found another paper that studied the mechanism of this in mice, and it showed that injury-provoked polio paralysis happens through a different mechanism than wild polio paralysis, but the result is the same. The person develops paralytic polio. I do have a government info sheet from the government of New Brunswick that's current and that states that strenuous exercise is a risk factor for developing paralytic polio. I have struggled to find papers to cite that back this up that wasn't talking about post-polio syndrome. However, it does seem plausible to me. When you exercise strenuously, you're making little tears in your muscles, which then regrow and you get swole. It is plausible that if the exercise was strenuous enough, that it might cause the same mode of action as the intramuscular injections, but I have yet to find some study that can show this with statistics. So for now, this is just a theory. If you have such a study, please send it in to me and I'll check it out. FDR was a fitness bro, though. He started to feel really sick while swimming in a lake. He was very active, so perhaps his exertions contributed to why he developed paralysis. One other thing that is variable case to case is where the paralysis is fixed, meaning how high you end up being paralyzed. FDR required a wheelchair. His upper body was basically functional, though, whereas many people, thousands in fact, were paralyzed much farther up their spinal cord, causing complete paralysis, quadriplegia, and the use of iron lungs to keep breathing, like we talked about at the beginning. That could be related to dosage of the virus that you get. It could be the part of your GI tract that the virus escapes from. So say if it gets out of your intestines, then you're paralyzed from the legs down. If it's higher, like the lymph nodes by the chin or the mouth, maybe that's when there's a higher chance of a more complete paralysis. I'm not 100% sure, and I didn't find anything that talks about that. Depending on what part of your spinal cord the virus infects depends on whether you're quote unquote just paralyzed or whether you pass away. Getting too far into the anatomy of the different sections of the spinal cord is a little beyond what I like to cover on this podcast, but briefly, so if you took a cross section of the spinal cord, I'll put one up in the show notes so that you can see the picture. Your spinal cord is basically round or oval shaped, right? Half of that circle is going to be closer to your chest. those are what's called the anterior cells, and your posterior cells are the other half, the ones that are closer to your back. It makes sense. I was raised in a household where we called your butt your posterior sometimes, so I think about that literally in my head every time I'm trying to figure out and remember which is anterior and which is posterior. So if polio affects your anterior horn cells, the ones that are towards the front of your body, that is what gives you paralysis. If it infects the ones closer to your backside, from there it can move up to and infect your thalamus and your hypothalamus in your brain and your brain stem. Unfortunately, if it does that, this is almost certainly fatal because the poliovirus is cytotoxic, meaning it destroys the cells it infects. Of the people who experience paralytic polio, 10 to 15% will die due to the brainstem involvement and the paralysis of the breathing muscles. Survival and some recovery can occur in some cases, though obviously not a full recovery, and people's condition can also stabilize long term after about 2 years post-infection. After the initial infection and symptoms, including paralysis, there might be some small improvement as your nerves try to re-innervate the tissues where the nerves were killed, but in general, the paralysis is permanent. If you have the kind of polio where you survive with or without paralysis, you're susceptible to developing post-polio syndrome anytime between 25 to 35 or more years later after infection. And this is something that can happen in approximately 25 to 40% of cases. The more severe your initial case and symptoms are, the more likely you are to develop this down the line. So post-polio syndrome, it's basically a slowed down version of polio. There's muscle and joint pain that gets progressively worse, and you become easily fatigued and exhausted. You start losing muscle mass, and breathing and swallowing problems begin to develop, including sleep apnea. Progression of these symptoms will come on and then plateau and then progress a little bit again and then stop and stabilize. But in general, the progression is as irreversible as the initial paralysis and regular polio. The age at which you catch polio initially also plays into this, with it being more common if you catch polio as an adult. If you happen to have paralytic polio, but you recovered quite a bit, then you're at greater risk. And if you typically engage in a lot of very strong physical activity, these are all things that can increase your likelihood of developing post-polio syndrome.
He has infantile paralysis, polio.
In the late summer of 1921, FDR was 38 years old. Tall, athletic, he was a current VP candidate of the Democratic Party and the running mate to presidential candidate James Cox. He and his family went to their summer retreat on Campobello Island in New Brunswick, right across the border from Maine, and the official reports say that he went swimming in Lake Glen Severn on August 10th and woke up the next day with extreme pain in his back and legs, which were so weak that he couldn't walk. He was examined then by Dr. Bennett. On August 12th, he was again so weak he needed assistance in walking and was complaining about urinary retention. By August 13th, he was completely paraplegic, and Mrs. Roosevelt called in a doctor from Maine called Dr. Keene. On August 14th, Dr. Keene arrived and examined him. Eleanor Roosevelt wrote about this in a letter to James Roosevelt, who was FDR's half-brother. You're going to hear about Eleanor again in a couple episodes. FDR's family was really worried, so Dr. Keene sought out Dr. Lovett, the physician I mentioned earlier as being the leading expert in polio. Dr. Lovett arrived by August 25th, and he began taking his case history and performing the examination. He wrote a letter in September that outlined that FDR went swimming on August 10th, but at the time he was already very tired before the swim. Shortly after the swim, he developed chills, a fever, and severe pains in the back and legs. During examination, it came out that he had had hyperesthesia, so increased sensitivity to touch, in his legs for a couple days prior to swimming in the lake. To me, this says that he caught the poliovirus well before his swim in Lake Glen Severn. It could be any time up to a month previously, and I don't think there's any way to know for sure where he caught it. In the movie, his campaign manager, Lewis Howe, says he thought FDR caught it at a Boy Scout camp, but since he was already sick in the days leading up to August 10th, I honestly find it surprising no more of his family or entourage came down with the virus as well. At the time of examination, August 25th, he was very tender, there was some facial involvement, though no respiratory problems. He had weakness in the arms, bladder paralysis, weakness in his legs and hips, and there was already some muscle atrophy 2 weeks after the symptoms began. In the movie, we see FDR unable to walk or to grab his doctor's hand, and he appears to be gasping or struggling to breathe and control his throat. Given that the actual medical notes don't describe him with breathing issues, this is likely just a little artistic license, but at least they picked a disease-accurate symptom to fake, because all of this is very much in keeping with the initial presentation of polio symptoms. Side note, the muscle atrophy happens way faster than you think it will. Maybe you think 2 weeks is, too quick for that to happen. I broke an ankle once and I was non-weight bearing on that ankle for about 2 months. And when I got my cast off at around 5 weeks, my poor little calf muscle was so skinny and shriveled compared to my other one. And that's just 5 weeks. It was noticeable then. So it does happen very quickly. Lovett's examination was quick and he left, but he was updated frequently by Dr. Keene and Dr. Bennett. By September 8th, so 4 weeks after onset, he was still experiencing low-grade fevers, and he had white blood cells in his urine, which indicates an infection. He was transferred to New York City under the care of Dr. George Draper on September 13th and was admitted with anterior poliomyelitis. At this time, he was having severe pain and paralysis in the lower limbs, weakness in his arms, and twitching of the forearms, and again, a drastic loss of muscle mass in the legs and buttocks. By December, FDR was seeing a physical therapist called Kathleen Lake, who noted in a letter to Dr. Lovett that the pain in his back and legs had gone, but his calves were still sensitive and his knees were constricting or falling inwards out of alignment due to the muscle atrophy. By May and June of the following year, FDR was wearing braces for his legs and undergoing an intense physical therapy program at Phillips House in Boston, which is an inpatient facility. They performed a couple assessments of what's called a manual muscle testing, or MMT, which thoroughly describes the symptoms of polio in all the affected areas, and it compares them to typical polio. And then you repeat this assessment over time to track either progress or regression of the disease. Doctors Draper and Lovett kept in touch about FDR's progress until July of 1924, when Dr. Lovett died at the age of 64.
George Foster Peabody. He owns a resort in rural Georgia for investment purposes.
The publication in news outlets and scientific journals of FDR's illness brought polio into the public's concern in ways that the outbreaks and thousands of deaths before that had not yet managed to do. Granted, it had only been 20 or so years since polio started becoming a major concern, but it was also largely happening to the lower classes and the poorer folk who were more frequently living in less hygienic conditions than rich white people did. In the episode on tuberculosis, I'm also going to talk a little bit about how decreased breastfeeding was common in the poorer working classes at this time and how that led to an increase in disease. FDR was the VP candidate at the time, like I said, and once his illness and paralysis stabilized, he went on to advocate for and support state-of-the-art medical care and rehabilitation for other people with polio. That is where Warm Springs comes in. A friend of FDR's named George Foster Peabody was part owner of a spa called the Merriweather Inn at the hot springs in Warm Springs, Georgia. He told FDR about the springs and about how they'd helped a young man with polio paralysis regain a bit of function. Roosevelt was intrigued and he traveled there himself and began swimming 3 times a day, and he would help other polio survivors who then traveled there due to the increased publicity. He even paid the costs for those guests who were unable to do so themselves because he saw and he knew how important this rehabilitation was. In 1938, FDR and his former law partner Basil O'Connor, they created a foundation to establish a national program to combat polio. It was called the National Foundation for Infantile Paralysis. The foundation's fundraising arm, the March of Dimes, which you may have heard of, became the most popular medical cause or charity in the world after World War II and was critical in raising funds for research that would go on to create the vaccines. By 1940, Warm Springs had over 400 residents and was the first fully accessible facility in the country. Because of his disability, Roosevelt understood exactly how important physical therapy and rehabilitation are after illness or injury. And in 1943, while president, FDR created the Office of Vocational Rehabilitation under the Federal Security Agency. This created comprehensive rehab programs for both veterans and civilians. Much of this is shown in the movie, or at least much of the beginnings and origins of him realizing these necessities and becoming more open to the plight of the common people, let's say. That all being said, I am just going to mention that FDR's presidency was not all sunshine and roses. I am not going to blindly sing praises here without acknowledging the other side of this history. I want to note, though, that I am not a history scientist and this is not behind the bastards, but I don't want to skip over this stuff entirely and just not mention it or pretend it didn't happen. He was president during the Second World War, and that means that not only did he refuse to sign an executive order giving immigration priority to Jewish people fleeing persecution, but he refused to allow the ocean liner St. Louis to land, which was carrying 900 Jewish refugees. It had to return to England, and there, maybe about 30% of those refugees ended up dying in the Holocaust due to his refusal. He was also the president who oversaw the setup of Japanese internment camps inside the US after the Pearl Harbor attack. He wouldn't sign an anti-lynching bill in 1937, although this was apparently because he thought it would cost him political capital that he didn't feel he could afford. It wasn't due to prejudice or anything, although I guess the result is the same, so it doesn't really make it any different. He also got tired of the Supreme Court being stacked by a bunch of old people born around the time of the Civil War, a problem that the US is still struggling with today, and he tried to get permission from Congress to appoint a new judge every time a current one hit the age of 70 and didn't retire. I think that's a pretty good idea. I can't fault him for that one, but his legacy is a bit of a mixed bag all in. I don't want to come across as if I'm, worshiping him or making excuses. That is not my intention. History is, to put it mildly, very messy. Once the true horrors of the Holocaust were becoming known in 1944, FDR did set up the War Refugee Board to aid people escaping the Nazi regime. Would have been nice if that had happened in 1939, but it is always better to change your mind and go back and learn something new than to never acknowledge you were wrong at all.
Some experts believe it's linked to contaminated water, but that theory is speculative at best.
So the polio virus was discovered in 1908, very early on in the field of virology. It was one of the first to be isolated. The first virus of any kind wasn't isolated and discovered as the agent of disease until 1892, and that was called tobacco mosaic virus. It causes this mottling on the leaves of the tobacco plant. The first human virus ever isolated was yellow fever, when it was shown in 1881 that mosquitoes were carrying the cause of that disease. At the time, discovering a virus pretty much consisted of showing that the disease you were working on was caused by something smaller than a bacteria or a fungi. Scientists did that by showing that out of an infectious solution, if they filtered out all of the things bacteria-sized and bigger, that the infection could then still be transmitted. At that size, smaller than bacteria, you're left with a virus or like a toxin or poison of some kind. The actual viruses themselves weren't able to be visualized or isolated until the 30s, when the electron microscope was invented. However, we knew they were there from the late 1880s or so. We just couldn't see them yet because regular visual microscopes don't have that kind of resolution. In 1907 and 1911, Ivar Wickman published some detailed epidemiological studies on poliovirus transmission following a Swedish epidemic in 1905 that saw over 1,000 cases. Wickman was meticulous in his publication of contact tracing, which was actually kind of revolutionary at the time because people were still struggling with believing that polio was transmitted person to person. At more or less the same time as Wickman published, Karl Landsteiner and Erwin Popper published in 1908 showing that they'd found the causative agent of polio, which they'd isolated from the spinal cord of a young 9-year-old boy who had died of the disease. Landsteiner, by the way, he was the guy who discovered the ABO blood groups when he worked at the University of Vienna, and he earned the Nobel Prize for that. And he was also studying Treponema pallidum, which is the bacteria that causes syphilis. It was difficult to prove polio existed because it is an exclusively human pathogen, so there were no animal models that scientists could use to infect and show the transmission and disease cycle, which is the cornerstone of Koch's postulates. I am going to talk more about those in episode 6. Landsteiner and Popper first tried rabbits, guinea pigs, and mice, with none of those being affected by polio, until they tried some monkeys, which came down with exactly the same symptoms as humans do. Those were namely lesions on the spinal cord and brainstem, and one rhesus monkey developed full flaccid paralysis. So isolating a virus is the first step towards vaccines. And the first polio vaccine made was the oral one, developed by Albert Sabin. Early vaccines were either a closely related pathogen that wasn't as deadly but still caused a protective immune reaction, like remember the smallpox vaccine, which was actually cowpox, but it protected you against the smallpox human virus, or they were what we call live attenuated versions of the human virus. Attenuated just means weakened in some way so it doesn't cause disease, but it still resembles the wild type virus enough that it produces the same immune response. You can attenuate a virus by what we call serial passage in something that is not human cells. That can be a live animal like mice or rabbits, or it can be chicken eggs, which is how the vaccine for yellow fever was produced. What you do is infect the animal or egg with the human pathogen, you let that animal get sick and produce a lot of virus, and then you re-isolate the virus. But mice and rabbits and chicken eggs are not human cells. They have different cell receptors, which means it might be harder for a human pathogen to enter the cell. So if it's going to survive and reproduce, the virus will have to be able to use those different cell receptors. Viruses are not all exact clones of each other. There can be subtle or not so subtle differences in the proteins or structures on the outside of the capsid, or say in the replication proteins that makes it better able to use the cell's internal reproduction machinery. Those viruses will be better able to produce new viral particles, which are then able to go on to produce even more and better suited particles. Basically, what I'm describing is evolution, but it happens very fast for viruses and bacteria, things that have a very short generation time. After you pass this virus through an animal or chicken egg multiple times, say a couple dozen generations, it becomes very well suited to reproducing in that animal's cells, and it's no longer suited to surviving in human cells. So then when you take that now rabbit-adapted virus and infect a human with it, it doesn't really know what to do. The human's immune system can attack it and destroy it before it causes disease. Then when the original human virus does infect that human, they will mount an immune response to it and not get sick. Sabin did this with polio in primates because, as I mentioned, primates are the only animals that polio can infect. He infected some primates and isolated virus from the ones who developed polio symptoms and did this a bunch of times before moving on to cell culture in petri dishes. And eventually he came up with a polio virus that was no longer good at infecting human primate cells. He developed this as an oral vaccine, so you just get a few drops of solution in your mouth. It goes right into the mucosa and begins producing a very strong antibody reaction in the GI tract where you normally encounter polio. So after Sabin developed the oral polio vaccine, the OPV, it began rapid human trials in the late 50s and early 60s in many different countries. But a key player in this was the Soviet Union. Now, there are risks associated with the oral polio vaccine for a couple of reasons. I mentioned at the top that there was this thing called vaccine-associated paralytic polio, or VAPP. The risk of this is different based on the different strain you were vaccinated with, as well as all the things I mentioned, like, muscular injury-induced polio. Polio is an RNA virus. DNA is deoxyribonucleic acid, and RNA is ribonucleic acid. So DNA has one less oxygen in its structure, and this makes it more stable. Oxygen is a very unstable element, and RNA doesn't last as long as DNA. It's not as complex, and the larger the molecule gets, the more unstable, so you do not see large RNA viruses or organisms. RNA also mutates more than DNA through its inherent instability during replication. RNA polymerases are very error-prone, but also through an ability to recombine and trade other genes with other RNA viruses. When the attenuated poliovirus comes into contact with other viruses in your gut, it can recombine with that virus that is not attenuated and then go on to cause disease, or it can just revert back to virulence through mistakes in the replication process. When you get an OPV, you actually end up shedding some of the virus in your stool. On one hand, shedding the virus is good because you can passively immunize your household if the virus doesn't recombine or mutate. but if it does, you or a close contact could potentially develop polio. These reverted viruses can actually start circulating in the population just like wild-type polio. So while we don't have wild polio strains 2 or 3 anymore, we do have some circulating vaccine-derived polios, which further complicates eradication. So why do we still use OPV if this is the risk? Well, firstly, because that risk is staggeringly low, only 1 or 2 cases of reversion per million doses given. Second, the OPV is very stable to store and transport. It doesn't need refrigeration, which means it's very easy to get to remote locations, to less developed nations and communities, and to get them vaccinated without the need for sterile needles either. We know the risk of reusing unsterile needles, as I talked about last episode. But due to this risk, the inactivated polio vaccine, or IPV, was developed. The OPV induces such a strong targeted immune response, and because it's still so easy to transport and give out, that's why we use it in places where polio is endemic or still circulates. In places where polio does not still exist, we use the IPV because while it doesn't induce as good a response, it does still give a protective one, and where polio doesn't exist naturally, that is sufficient. There is information out there and in my sources that debates the use of 1 dose of OPV and then 1 or more or 2 of IPV, which is better, what level of response is induced. It's this whole thing that I'm not going to cover. All I will say is that we are very close to eradication, so now is not the time to give up. It's time to buckle in and work even harder to get the last strains of polio gone. Overall, I'm going to say that I think Warm Springs was very accurate. They showed the symptoms and the progression of the disease really well, and Kenneth Branagh did a great job acting through the illness and displaying the paralysis. So I'm going to have to give this movie a solid 9 out of 10 test tubes for accuracy because they got most of it bang on. And that's all I'm going to cover for this episode of Tierah Ruins Things with Science. I am a researcher and not a doctor, so please don't take any of this as medical advice. It is for entertainment only. You can follow me on Facebook, TikTok, Blue Sky, and Instagram at Tierah Ruins Things, and you can find all kinds of things at Tierah Ruins Things on Substack, like the show notes and pictures and a transcript for every episode and sources. Also there you can find reading and listening lists, places where I recommend science books and podcasts that I've been listening to and enjoy. Also on Substack, you can support me ruining things by becoming a paid subscriber, or you can join my Patreon if that platform is more your vibe. With either of those subscriptions, you'll get access to upcoming bonus episodes and future Q&A sessions where I answer your submitted questions about infectious diseases. I do all the research writing and recording and editing for this show. The theme song this season was written and provided by iEffigy, and you can follow them on Spotify. There is a link. If you have any suggestions for TV shows or movies featuring diseases or pathogens that you'd like me to cover, or questions you'd like me to answer about this show or any of them, send them in to tierahruinsthings@gmail.com, or you can get in touch on any of the social medias that I mentioned. See you all next episode where I will be talking about smallpox and the movie Winter Hawk.